Hello, everyone. Welcome to today's episode of Career Jumpstart. In this episode, we'll be talking about technical questions, how they pertain to the technical interview. I'm Jared. I'm one of the technical peers with the Letty Career Service Office.
And I'm Connor. I'm also a tech peer within the Letty Career Services Office. You can schedule meetings with either of us to practice your technical interviews after you watch this video. So, what material to expect? When you get to a technical interview and you start working on a technical question, there are a lot of factors that'll play into what material you can expect for the technical questions. First of all, anything you put on your resume is fair game. Secondly, you want to have a focus on data structures and algorithms, as these are the types of things that will be considered for technical interviews. Focus on the time complexity of your solution. Think about how choosing a specific language will affect your solution. And then there are going to be different complexities within the problem, such as maybe finding bugs or specific more overarching design challenges that focus on identifying different ways to solve a problem. A lot of this information can be gleaned from resources like Glassdoor, though. Glassdoor, you can find actual people who've gone in and interviewed with these companies and shown or told how that interview process went for them. They'll give you information ranging from the types of questions they saw to the number of rounds of interviews that were in the process.
So let's talk about whiteboard questions. So the big part of technical interviews, you might have like 5-10 minutes at the start of just like a behavioral kind of getting to know your interviewer, make the environment a little comfortable. But after that comes the whiteboard question. The whiteboard can be like when you're in person and you're physically writing on the board, but with the circumstances now, this is most likely going to be a virtual format where you're going to have a document in front of you, like a shared document, and you and the recruiter will be working on this same shared document, and they can see the code that you're writing. So the process is still the same. It's just a little different because you're not physically writing the code, you're just typing it on your computer. So to start, you're given a question, and with the question, you really want to clarify. So they'll ask you the question and you want to make sure you understand it. The biggest thing is understanding the question before you go to start coding it. So many people mess up this part where they really don't understand the question before they go and start to code it. And that really is a detriment to them later on in the process. So the best part to clarify is to try to paraphrase the question. So if they ask you the question, try to summarize it into just a few sentences or into one sentence saying, is this what you mean? Is this what I should be doing? And they'll give you yes or no. You should specify your input and your output. So what you're given and then what you need to produce with your code. You should clarify your edge cases and try to identify which edge cases are going to come up with this code. You should also briefly write your function method or your header. That way, once you've asked your input output, you immediately can write your function header because you know what those are right away. Your input are going to be your arguments and your output is going to be the return type of this function. You should also ask what utility functions you can use. So maybe you have a code that requires the use of a queue. You can ask, can I use the built-in Java queue, the built-in Python queue, or do I need to make my own queue? And ask questions. Again, make sure you fully understand the problem before you go and start to code it.
Next, we want to consider what the problem is. Now we know what it's actually going to ask of us. What are some examples? Can we think about how we want to approach the problem by thinking about the edge cases that we've already listed off and how they'll affect our overall solution? Again, think about our inputs and outputs. And if you yourself can't think of a test case, it's always good practice to ask the interviewer for a test case because that gives them an opportunity to pick one that they think exemplifies the problem well. Once you've already kind of chosen a test case and worked through your initial thought process, you want to start discussing with the interviewer out loud how you would solve it. Think if you were the computer. Talk through your brute force solution first. This is often a solution that is simple, inefficient, but effective. Might take a few lines of code at most, or in other worse situations, many lines of code, but it's straightforward. Once you've kind of talked through your brute force solution and you have at least one working thought process, find a now more complex solution to the problem, and talk in terms of time and space complexity if you're familiar with it, to understand better how you can approach the problem and come to an efficient and effective solution.
So then you want to review. After, say, you've written your code, you should always try to review it. Review the stuff that you've came up with. This review should happen throughout the entire process. If you have written the code, you should review the code. If you've came up with a thought process, like how I should attack this, how I should handle it, you should review that. So this major part here is specific towards reviewing your thought process behind solving the problem. So you can talk out a solution with the reviewer or the recruiter, but then you should review it and think about your solution. Is there anything inefficient about it? What can you speed up? Maybe you're using a double for loop, nested fors. Maybe you could change that into using, say, a hash map in one for. So that's also into the second point. Are there data structures you can use? In that case, you could use a hash map and store things that you've seen in the past in an array, for example. And then it improves the runtime of your solution. And then how long does the problem take to run? So you should also really think about how the runtime of the problem is affected by your solution. Think about, is there ways to speed it up? Think about what data structures you can use to speed it up. This is mainly just talking through your thought process in order to make sure that you're on the right track and you have a reasonable approach to the problem. So after that, you want to code. This is the point you've been waiting for, is the big coding part. So you should write out your code, and when you're writing your code, you want to talk about what you're doing. You don't want to just monotonously write your code. You really want to involve the interviewer. Make it like a conversation with the interviewer. So as you're coding, you want to write, okay, this is why I'm using a for loop here. This is why I'm using a while loop here. You should talk about your variables. So if you have a variable that needs to store like a count, for example, why are you using that variable? Talk about what it represents. Maybe you've used certain data structures in your answer. You should be able to talk about why you're using those data structures and what the benefit is to using them. So as you're writing it out, you can say, okay, in this one, I'm going to use, like, I could brute force it here by using a nested for loop. However, I want to use a hash map here because that's going to improve my runtime. I only need to do one for loop, and then I just have this hash map that's growing. And space is very okay to sacrifice if we can save time. If we can go from n squared to n, then going from constant space to n space is not that big a deal. Because space is cheap, but time is costly. You should use your space in an organized way. So oftentimes you might get to the point where you're at the bottom of the whiteboard and you have no room left. You're gonna have to like try to figure out a way to go back up to the top, or maybe you left out a code segment that you should have put in, so now you have to draw an arrow and like insert it. That's more geared towards like whiteboard when you're writing on a whiteboard, but make sure you're using your space wisely and make sure you're keeping it organized, because it makes it easier for you to read and it makes it easier for the interviewer to read. Don't get caught up in language specifics and small details. Say you're writing Java and you're mainly like a Python programmer or something, and you felt that Java is the most appropriate for this one. Say you forget to put semicolons. That's not that big of a deal, because that's just some small factor of the syntax. The biggest thing about the code is your thought process. Your thought process and the logic that goes into solving it. So you really want to make sure that you have that logic and thought process down. Syntax errors aren't that important, but you should try to code correctly, obviously. But if you're getting caught up on, oh, do I need a semicolon here? Do I not need one? If you're getting caught up on something like that, just try to pass it over. And such small stuff like that, if you were to ask the interviewer like a question like, oh, I can't remember how this for loop is. I don't know if there are commas or semicolons in here. You can ask something like that, because it's just such a small piece of the overall solution that it really isn't that important if you can't remember that. You should also use clear variable names. So instead of doing like int xyz, you should have like int count, int int return, stuff like this that's like obvious to what that variable is. You should also write legibly. No one likes people they're like really bad handwriting and you can't even read their solution. You should always write so that the interviewer knows they can read it and they can understand what you're doing without having to put much effort into it.
So finally, once you've written some code, you've already got your test cases up on the board. You want to walk through those test cases so you can ensure that your code will work. Consider each element of your code as you go through line by line with your test case, and ensure that each edge case works, and fix your bugs as you meet them. That's the whole point of this part of your code. Find issues before your interviewer finds them so that you can improve your solution and ensure that it's looking as best it can. Finally, you've gotten through all of your code, you've tested, you now just need to summarize your approach. Look back at the interviewer, you're sure that your code is working, and talk them through your approach in a concise manner. Answer their questions, they're going to have some, and analyze again your code in terms of time and space complexity. This is the time to summarize everything. I know that my code will run in O(n) log n time because I've chosen to use this structure to represent or hold this piece of the information, and this structure to represent or hold this piece of the information using one loop and X loop. This is really your bread and butter final moment when you know that you've got the interview. So finally, here are just some tips. We want to go over just, again, the basics that we were talking about. We talked about edge cases. Here are some example edge cases that you might need to consider. For integers, you might want to consider the negative case, the maximum or minimum values. Is that ever going to be an issue for you? If you're working with objects, consider what happens if you're passed a null object. If you're working with array lists, empties. And then just think of other exceptions that might pop up in your code. If you're looking to optimize, think about how, again, a data structure might help. Our advice is, look, you can always consider a hash map dictionary or set first. They're used in a lot of these problems, and they're very effective. Jarod?
Yeah, so make sure you are just going over everything. If you're stuck, you can ask your interviewer briefly for some information. So maybe you're writing a solution out and you're a little stuck on it. You can ask for a little bit of a push forward, and most likely they'll be happy to help kind of guide you forward. They're not going to tell you how to solve it, but they'll give you some help. You should also think about what you want to say out loud and why you want to say that out loud. Why you're using a for loop versus a while loop. Why are you picking this data structure, and why do you need this variable? So kind of some of the stuff we went over earlier, but it's very important to talk about that, because that's the major focus point of the interview, is your thought process, how you're thinking about the solution and how you're thinking about your answer and what goes into the solution. So yeah. Here we have some free practice resources. I mean, it's not our free practice resources, but these are 3 websites that have a lot of available resources out there for you to practice with. LeetCode's probably the most commonly known website, has probably, I think, like 1,500 questions all ordered. Yeah, 1,500 problems all ordered, like easy, medium, hard, by different like data type, or not data types,
data structures and companies that use them. There's a lot of information there. I would say this is something that we preach in our office. Talk yourself out loud through these problems as if they were an interview. If you just sit and practice these problems by coding them out, you're going to get good at the problems, but that's only half the interview. The other half is how you present yourself and how you present the problem.
And then there's also HackerRank, which is pretty similar to LeetCode. However, they have some cool little like kits, like an interview prep kit, which will give you problems associated with all the data structures, just to get you to practice. And then Code Signal's kind of a newer one that's coming up. So all 3 of these are 3 very good resources for you to use and to practice with.
Don't forget, your final resource is the Luddy Career Services office. Myself, Jarod, and our third coworker, Jason, are here to help you and help you practice for these problems. You can schedule an appointment with us, schedule a mock technical interview, and we'll go through and guide you as if you were working on a practice problem, or rather as if you were working on a problem in an actual interview, in an open practice setting where you have the opportunity to learn from your mistakes. So, final advice, go out there, practice, and ace some technical interviews.